All right, in section 5.1, we're going to look at the basic trigonometric identities. We're going to look at memorizing some of the identities and learning how to use them when we want to do some simplification. First thing we need to know, what is an identity? An identity is an equation that's true for all values of the variable, true all the time. When I take a plus b and I square it, when I multiply those together every single time, I'm going to get a squared plus 2ab plus b squared. So I know that that's true always. X times x plus y. When I distribute that x through, it means it's equal to x squared plus x times y, and that's true all the time, no matter which value that I would have for x and which value that I would have for y. All right, another thing we need to know before we move forward, exponents with trigonometric functions. One thing that we want to make sure that we're clear on, if I have sine of x to the fourth, if that 4 is on the outside of the parentheses, that means that I've got the sine value multiplied by itself 4 times, as you see here. And what we do, just to eliminate some use of those parentheses, which can get kind of cumbersome if you have a lot of trig functions and exponents in one expression, is that we end up writing that 4 in between the sine and the x value there. So that's going to be a notation that you'll see pretty often. What we want to make sure that we can relate that to is, what if I had the sine and I just put x to the fourth here without any parentheses? What that means is that you have here the sine of now 4 x's, x times x times x times x. So we want to be careful about our notation. When you see the 4 in between the sine and the x, that means it's the same as the entire quantity of sine raised to the fourth. If I have the 4 in this location, as you see in my pen here, now that's just the x being raised to the fourth instead. All right, so one thing that we want to be able to fill in on the trig identity sheet that you have, most often that's going to be a green sheet that I would print for you. So on that green sheet with your trig identities, we're going to write down what they are one more time. The reciprocal identities, I know that you already know these, but we're going to write them down again just to make sure. So on that identity sheet, those are the first 6 that you see here. We've already talked about these, so just reiterating, sine is the reciprocal of cosecant, cosine is a reciprocal of secant, tangent is the reciprocal of cotangent, and then vice versa on the right-hand side. So you're filling them in on that trig identity sheet. With those trig identities, given that the cosine is 0.75, we want you to figure out what the secant is. Now remember that the secant, as we have written above, the secant is 1 over the cosine. So if we're going to figure out what the secant is, then we know that the value of the cosine was 0.75, so 1 over 0.75. Now 0.75 would be the same as 3/4, so 1 divided by 3/4 is going to give me 4/3 as a final option there. Okay. Now, one other thing that I want you to write about the reciprocal identities, and I'm just going to write it right up here. You're probably on that trig identity sheet. You can write it right in this location, except for I'm not going to have enough space there. The reciprocal identities work with any exponent. And because they work with any exponent, one thing that you'll see, for example, let's just use the cosecant that I have here. If I was going to write the cosecant of theta, and I'm going to square that, well, that would be the same as the cosecant times the cosecant, which could be written as 1 over the sine times 1 over the sine, and lo and behold, what that gives me in the end is 1 over the sine squared. So what just happened here is we had the cosine squared, and it was the same as 1 over the sine squared. So when this was squared as my exponent, it's squared right here. That works with any exponent that I have. So in other words, if I get rid of the 2's there, maybe I have cosecant to the 5th is the same as 1 over sine to the 5th. So these reciprocal identities are true when they're raised to the first, but it's also true for any exponent that I might pick. All right, then the quotient identities, the next ones that you have on your trig sheet. So again, they're listed on your trig sheet like you see on this number 1 and number 2 here on the top. When I'm putting them on my trig identity sheet, I'm going to again write that these work with any exponent. Now, what you might be thinking right now is, well, why am I writing this each time? That should be a hint to you that because I'm writing work with any exponent now, there's probably going to be something along the way that doesn't actually work with any exponent that I choose. Our quotient identities are the tangent is the same as sine over cosine, and the cotangent is the same as cosine over sine. Again, you're going to work on memorizing these identities. That's going to make the rest of our work in the chapter a lot easier. So memorize our reciprocal identities and also our quotient identities here. What we're reminding you of here where it says recall tangent is y over x. Remember that triangle that we used in chapter 4 with the unit circle where we had our angle and then we said this is x, this is y, and this is our r value on the unit circle. That r value is equal to 1. When I look at this triangle, I can see that the tangent opposite over adjacent, my tangent values are y over x. And we also remember from the unit circle that the y value tells me the sine and the x value tells me the cosine. And so from that triangle from chapter 4, the tangent is y over x, which we know is the same as the sine over the cosine. So that's where our tangent comes from that same exact triangle. And again, it works with any exponent, and because it works with any exponent, tangent squared, tangent times tangent, writing those as sine over cosine, and then you get the sine squared over cosine squared. So true no matter what exponent that we decide to use. All right, so let's do a little bit of simplification before we move on to the rest of our identities here. As we do our simplification, we're going to start to fill in what you see on the bottom of your trig identity sheet where you've got the strategies to simplify. So these strategies to simplify, again, you're going to want to commit those to memory. And the first strategy that you're going to write down as we simplify is that changing to sines and cosines is a good idea. So in option number 1, we're going to write use sine or cosine. Okay, and how are we going to do that? Let's check out letter A and letter B. In letter A, you've got the cotangent times the sine. Well, this already has a sine in it, but now you've got the cotangent. So what we're going to do is we're going to rewrite that cotangent using your quotient identities. And with that quotient identity, I'm going to say that the cotangent is the same as cosine of theta over sine of theta. And I'm going to multiply that by the sine of theta. Now, when I do that multiplication, what happens, of course, is that the sines are going to disappear, and that's going to simplify to the cosine of theta. And that's my final answer for letter A. In letter B, now we're looking at the tangent times the cosine squared. Same idea. We're going to change things to sine and cosine if we can. And so the tangent we're going to rewrite as the sine over the cosine. Looks like we're multiplying that by the cosine squared. Again, a cosine that's going to disappear one of them from in the numerator, this cosine in the denominator, leaves me with sine times the cosine. Sine and cosine are considered our most simple trig identities, so when you have sine times cosine, I can't simplify that any more than what I already have. All right, our last identities that we're going to be looking at on your trig identity sheet are these Pythagorean identities. So we're going to come up with 3 of them all together here. To come up with our Pythagorean identities, we know that the equation for that unit circle from back in chapter 4 was x squared plus y squared equals 1. Again, back to that triangle that I just drew for you on the other page where we had x, y, and then our radius, which was equal to 1. So when you do the Pythagorean theorem, you get x squared plus y squared equals 1. Now, if we think of our equation for the unit circle and now replace with the trig functions, we said that x was the same as the cosine, so we can write this as the cosine squared, and y was the same as the sine, so we're going to write plus sine squared equals 1. So cosine squared plus sine squared equals 1. A lot of textbooks will actually flip that around and say that sine squared plus cosine squared is equal to 1. It obviously doesn't matter since it's just addition there. So in your Pythagorean identities, your first Pythagorean is sine squared plus cosine squared equals 1. Now once we have that first identity, that's kind of the main one of the Pythagoreans that you're going to want to commit to memory. The other two we're going to find by modifying this one slightly. So if you can memorize sine squared plus cosine squared equals 1, that's going to pop up a lot. You're going to be able to derive the other two equations from that. So starting with our basic sine squared plus cosine squared equals 1, we're going to divide each term by the cosine squared. And so by dividing by the cosine squared, you're going to be able to come up with a brand new identity. So if I take this and we'll divide by the cosine squared every single term, divide by the cosine squared here, looks like what are we going to end up with now? We're going to have sine squared over cosine squared. Well, that was equal to the tangent squared. So we've got the tangent squared of theta. Cosine squared over cosine squared is 1. And 1 over cosine squared using those reciprocals gives me a secant squared. So that's going to be your second Pythagorean identity. So by number 2, you're going to write that the tangent squared plus 1 is equal to the secant squared. You already have sine squared plus cosine squared equals 1. And to come up with our third identity, we're going to do the same thing as we did up above, but we're going to instead divide by the sine squared instead of by the cosine squared. So dividing all of these things by the sine squared here. Just quickly write that under each of them. And you're already thinking about what that's going to give you for a final answer. When I do that division, sine squared over sine squared is going to give me 1. Cosine squared over sine squared is going to be the cotangent squared. And 1 over the sine squared is going to be the cosecant squared. That's my third trigonometric identity for our Pythagorean identities. Okay. Now, each of these 3 Pythagorean identities, a couple of things that we need to know about those. The first thing that I want you to write on your trig identity paper, unlike the other ones, these Pythagorean identities only work with an exponent of 2. So the other ones worked with any exponent. This time around, these only work with exponent 2. If this is sine plus cosine, that is not equal to 1. And you could try that on your calculator. Use 30 degrees. Sine of 30 degrees plus cosine of 30 degrees is not equal to 1. So these identities are only true if those exponents are 2. They do not work if they are 1. They do not work if they are 3. They do not work any other time. The other thing that's helpful to know about these identities is that they also work in some other scenarios where perhaps you might be rearranging the order. And so sometimes people like to write them on their trig identity sheet. Sometimes it's just something that you can figure out in your head. But if I had, for example, sine squared plus cosine squared equals 1, another identity that's going to be pretty common for us to see is that sine squared equals 1 minus the cosine squared. And likewise, cosine squared equals 1 minus the sine squared. So each of our, what I'm going to call main identities, have 2 other identities if we solve them. And these occur pretty often in the problems that we're going to do in this section. So we just want you to be aware of that. Again, you can write them down next to these identities on your trig identity sheet, or you can just kind of figure that part out, but just be aware that you're going to see them in a few different forms. All right. Our strategy number 1 was to use sine and cosine. Sine and cosine. And our strategy number 2 that we're going to see when we get to this next example as we simplify is to use those Pythagorean identities. Send a couple letters in here, identities. All right. So as we're using those Pythagorean identities as another strategy, as we check out example number 3, we have a couple options as to how we can solve. And so we can either use Pythagorean identities or we can change things to sines and cosines. Kind of all depends on what you see first as you're going ahead to do your simplification. So to show you both of those, we're going to have 2 different options that I'm going to walk you through here. Option number 1 for how I might choose to simplify this one. I might choose to do some factoring as my first step. And so if I use factoring as my first step, what I'm going to do is when I look at this one, I see I have a sine squared in each term. So I'm going to factor out a sine squared. That leaves me with cotangent squared plus 1. Now that I have cotangent squared plus 1, well, what am I going to do with that? Sine squared, we said sine was the most basic of our trig identities. So what happens with the cotangent squared plus 1? Well, you're going to work on memorizing those Pythagoreans, but when I look down on my trig identity sheet, I'm going to see that cotangent squared plus 1 is equivalent to the cosecant squared. So we're going to replace this part with our cosecant squared. And then we're going to multiply those together. We know that the cosecant squared is the reciprocal of the sine. Remember, it works with any exponent, so cosecant squared is 1 over sine squared, and all together we end up with a 1 for a final answer. Okay. Option number 2, which is going to give us the exact same answer, but just to show you that oftentimes there's more than one way to do a problem. If I'm going to do option number 2, I'm going to use that first strategy of changing things to sine and cosine. And so as I do that, when I look at my first set, I've got the cotangent, and I'm going to replace the cotangent with cosine squared over sine squared times the sine squared plus the sine squared. So if instead of factoring and then using a Pythagorean identity, maybe I first look at that and say, hey, I'm going to change everything to sines and cosines. So I change the cotangent squared to sine and cosine, or in other words, cosine squared over sine squared. And now I'll simplify. The sine squareds are going to disappear. That's going to leave me with cosine squared plus the sine squared. That was one of our Pythagorean identities, right? Cosine squared plus sine squared, that's going to be equal to 1. You notice that in both steps, it didn't really matter which one that I started with. So in the first one, even though I factored, once I factored, I used a Pythagorean identity, and then I switched to sines and cosines. In option number 2, first I changed to sine and cosine, and then I ended up doing a Pythagorean identity. So in a lot of cases, there's more than one choice, and it turns out most of the time, it doesn't matter what you choose to do first. It's going to look a little bit different in your problem-solving strategy, but in the end, you're going to end up with the same solution. All right, example number 4, we're going to simplify sine of x plus the cosine of x, that whole entire quantity squared. Now, as we're doing this question, how are we going to do that? Option number 1 said use sines and cosines. Well, it already is sine and cosine. So then what are we going to do after that? I guess I don't have a Pythagorean identity, which is what we had in option number 2, nothing is squared in there. Since the entire quantity is squared, what I'm going to do is I'm going to multiply those together. And strategy number 3 is going to say that sometimes we will factor a common factor out, sometimes we will distribute, or in other words, multiply some things together. So if you have something in common, you might choose to take it out. Otherwise, you might choose to do some multiplication and distribute things together. And that's what we're going to do in this one. So we're going to square it. Some of you know how to square that without writing the 2 binomials out. Some of you like to write the 2 binomials. So you can decide what works best for you. So for now, I'm just going to write it so we're all clear on where those values come from. So as I multiply my first terms together is going to give me a sine squared. My outside terms here looks like it gives me a sine times a cosine. My inside terms also a sine times a cosine. And my last terms look like they're going to give me a cosine squared. All right, now as I try to simplify those, we're going to say, what can I do? How can I group these together? The first thing that I see, sine squared plus cosine squared. Hey, that's one of those Pythagorean. Sine squared plus cosine squared. Magic, that's one. Then we've got sine, cosine, that's in there twice. So we have plus 2 sine, cosine. And that's all we can do with this one. Again, sine and cosine, the most simple of our Pythagorean identities. So that's going to be as simple as this one gets. All right, so we've got 3 strategies so far. Change to sine and cosine for the first one, Pythagorean identities for the second one. We just looked at factoring and distributing, and now in this example, we're going to look at how to create a common denominator. So you're going to write that one as option number 4 is making a common denominator. Okay. We're not actually going to get to option number 5 until we do section 5.2. So for today, those are going to be our 4 strategies that we look at. As we create a common denominator here, we notice that neither denominator has any common factors with one another right now. I'm going to just space these out so I have a little bit of room to write what I need there. Since neither denominator has anything in common, that means that in this first fraction, I'm going to go ahead and multiply this by the cosine on the top and on the bottom. And then in my second fraction, it already has a cosine, so it looks like that one's going to be multiplied by 1 minus the sine. Okay. So as I just created that common denominator, looks like I'm going to have my entire denominator will be 1 minus the sine times the cosine. So you see those denominators are both going to be 1 minus the sine times the cosine. So I'm just going to combine those together right now. My first fraction in the numerator turns out to be the cosine squared. Now I'm subtracting here, so watch out for that. Sine times 1, so that's minus the sine. And then sine times a negative sine would be negative sine squared, but remember I'm subtracting that, so that's going to be plus a sine squared. Just a couple more steps for us. Again, work on memorizing those identities so that when you write this question down, it kind of just comes to us a little bit faster in terms of what identities that we can choose to use. So in this one, because we're memorizing those right away, we see this cosine squared plus sine squared. It's like magic. Cosine squared plus sine squared, that's 1. 1 minus the sine of x on the numerator, and then, oh, look at that in the denominator, 1 minus the sine of x again times the cosine. These 1 minus the sine values are in common, so I can eliminate both of those. That leaves me with a 1 over cosine. From your reciprocal identities, we know that that is equal to the secant. So our final answer there is the secant of x. All right, last part of this section is looking at factoring trigonometric functions. And as we look at factoring the trigonometric expressions, we're going to factor what looks to be quadratics, right? You've got a squared here, you've got a squared here, you've got a squared here. So we're going to be factoring these just like we would factor quadratics. Now, we practiced some factoring during our Fun Factor Friday, and it was a little bit trickier for us when it wasn't just the regular old x's that we're used to. So one strategy that I often recommend to students as you start learning how to factor when you have a trig function in your expression is maybe instead of leaving it as cosine squared and cosine, maybe do a little substitution. How would I factor this if it was x squared plus 2x plus 1? Well, that we would know how to do. We would know that that would be the same as x plus 1 times x plus 1. Okay. Well, for us, instead of having an x, we had a cosine. So cosine instead of x, which means if I'm going to factor my original expression, my true answer for what I'm looking for here is cosine plus 1 times cosine plus 1. We'll use the same idea when we're factoring in letter B, sine squared plus 6 sine plus h. So instead of looking at it with the trig function in there, if it helps you out, go ahead and write that in there with x's. Some of you right now are like, I don't need those x's, I can factor how it is. That's great. Some of you are going to use the x's to start and then eventually say, oh, I don't need to write that anymore. And some of you will use the x's the entire time. So whatever works best for you is just fine. It does help a lot of people to be able to get rolling on the factoring. So don't be afraid to use that. All right, how do we factor that? Of course, that's going to be x plus 4 times x plus 2, so that it multiplies to 8 and adds to 6. And again, since we're really looking at a sine function and not an x, that means that we really have the sine of x plus 4 times the sine of x plus 2. All right, and last one, this one's actually a pretty common one, and you'll see that a few times in your homework, 1 minus the sine squared. Well, how do I factor that? I know that a lot of you like to write the squared term first and as a positive number, but we really want to try to leave this one without putting the squared term first. So let's see what we can do here. I'm going to write this as 1 minus x squared. And when I look at this, hopefully you recognize that as a difference of squares. So even though the squared term isn't first, it still is a difference of squares. The square root of 1 is 1, square root of x squared is x. And so that means it's going to factor into 1 minus x times 1 plus x. Okay. Again, we're not having an x. We actually had the sine function in there. So we're going to say this is 1 minus the sine times 1 plus the sine. And that will be my final answer for the factoring. Now you heard me say that this one gets used a lot. Why does this one get used a lot? If you are remembering your Pythagorean identities, that's one of those that we just looked at where we said sine squared plus cosine squared was equal to 1. So sure enough, 1 minus sine squared, remember how I said you could manipulate that. If I subtract the sine squared to the other side, cosine squared is the same as 1 minus the sine squared. So this 1 minus sine squared is equivalent to the cosine squared, which is why this part of it gets used pretty often. Okay, so that's factoring with our trig functions.